The empirical method, let's see the definition. All right, so the empirical probability of an event and we'll call that event E, and we're using capital letters for E. So the empirical probability event E is the relative frequency that E occurs in a sample or an experiment. So basically, we estimate the probability of this event, right, by using the proportion of times that E occurs. Right? So, which is, again, is the relative frequency of E. And so this is the count of the event occurring over the total count. All right, so relative frequency is a count over a total count. So we say, well, how many times did E occur? How many times did we try it? Sometimes the notation for the count of E, sometimes we'll use like the number in E, right? N of E. And then here, usually when we're talking about the total count, we have N, little n, or the N of S. You know, how many, remember S, this is the sample space. This is all the different ways that something can occur. And so the number in the sample space is the number of different possibilities, and then we count the number of ways E occurs. All right, so an example might be, I want to know what proportion of chefs prefer Italian. So I take a sample of 53 chefs, and let's say that 17 of them, so they prefer Italian to other types of foods. So then I would say the probability that a chef prefers Italian food, and this would be is approximately equal to 17 over 53. And this is 0.3, 321. All right, so about 32% of chefs prefer Italian to other genres of food. So what does this mean? So when you look at this, we can also convert this to a percent. We do that by multiplying by 100%, which is the same as we're going to move this decimal 2 places. So this is 32.1%. Right. And what that means, if I ask 100 chefs, I expect around 32 of them to prefer Italian. Another example. This is an example of a frequency table. On here, I took the NKU enrollment as of 2018 to 2019, so last year, and split it up by class. So we have freshman, sophomore, junior, senior, were they a graduate student? And we have this undergraduate other, I'm not even sure what that is. And here's the total. So in order to calculate the probability that a randomly chosen student is one of these, you can see here, I don't know, my first problem. All right. So when we randomly choose a student, it means every student is equally likely. All right. So I pick a student, what's the probability that they're a junior? So the first thing I'm going to do is I'm going to establish the probability model. And the probability model is a list of all possible outcomes with the probabilities. So here's a freshman. So the probability that a randomly chosen student is a freshman is going to be the proportion or the relative frequency that it occurs. So frequency, again, means the count. Relative frequency is the proportion, which we are now using, because this is an empirical probability, as the probability. All right, so probability, proportion, relative frequency all mean the same thing when we're talking about an empirical probability. So in order to get this guy, this frequency, we get the count, which is 2451, and we divide by the total count, which is 15,687. All right, so what I'm going to do is I'm going to copy this table into Excel so that I can calculate all these at one time. All right, so I'm going to paste that table here. Make some room for this stuff. All right, so here's my total and here's my freshman. So what I want to do is I want to divide this guy by this guy. All right, so I'm going to make a formula. I type equals. Every time you put a formula in, you use equals. And I'm just going to take my mouse over here, click on that guy, and then I'm going to divide by the total. And that gives me my answer, 0.156. All right, so I'm going to reduce the number of decimals just to 3. I'm going to make this a number, and then I'm going to increase it. There we go. So 0.156 to 3 decimal places. All right, so now I want to do the same thing for the rest of these. Now, if I copy this formula down, what's going to happen is it does what's called, it's going to change the formula. So if I copy down one, it's going to look at this one, and then it's going to divide by this one. Which I don't want it divided by this one. I want the total to stay the same. In order to get this to stay the same, I have to put dollar signs around the B. All right, and there's one way you can do that is if you have a PC is to hit the F4 button and then put dollar signs around it. Otherwise, you just type the dollar sign, B dollar sign. All right, so when I do that, now if I copy this down, I'm going to hit Control C for copy, Control V for paste. Now it says, okay, now I'm dividing this guy divided by B9. And so then if I want to copy all the way down, I can grab this corner here and then drag to here. Okay. And then if I want the total, there's this thing over here called auto sum. I just click on it and then hit enter and it totals it. So it sums to 1, which it should. The proportion will all add to 1. So here are my relative frequencies, and they were for my probabilities of a relative or a randomly chosen student to be any of these categories. So we asked, the first one was what about a junior? The probability that a randomly selected student is a junior is 0.145. All right, so what I'm going to do, I'm going to type in these relative frequencies. So I got 0.156, 0.127. I got this from the Excel sheet. 0.145, 0.203, 0.023, 0.115, or 0.231, and of course these add to 1. All right. Or I can use the percent, which I would get by multiplying by 100%. So the relative frequency is 0.156, or it's 15.6%, etc. 12.7, 14.5, all the way down. And then these would all add up to 100%. So if I want to know what's the probability that a randomly chosen student is a junior, I come over to junior. There's my probability, 0.145. So let's put the probability of a junior equals 0.145. All right, then it says estimate the probability that a randomly chosen student is an undergraduate other. All right, so undergraduate other, this is this guy, this is 0.023. We'll call him probability of undergraduate other is 0.023. And then it asks, would that be unusual? All right, so remember what unusual means? Unusual means that the probability is close to 0. It's small probability. And specifically in statistics, which we're not really doing statistics right now, we're doing probability, but in statistics, if it's unusual if the probability is less than 0.05. So 0.023 is less than 0.05, so the answer is yes. So it would be unusual that if I randomly chose a student, that they would be an undergraduate other.